Alright, hey everyone. This is question number 3 on the 61A Fall Midterm 1 2020. And so if you don't know how to get there right now, 61A 61a.org resources, and then we want to go to Fall 2020 exam. And the solutions PDF is non-existent right now, but we'll get that fixed in a bit. So this thing right here. And so let's get started. Oh yeah, also one thing to note, I know on the discussion it says like question 11 is reverse environment diagram practice problem, but please don't do that. Please don't do that because it involves non-local and that's not in scope for this semester. So yeah, let's get started. So for environment diagrams, I like to get started by taking a look at what we have so far. So we defined the vote function right here. So if we notice in the global frame, we like take that, and then so we don't have to do anything with vote anymore. And then we have ty equals 1. So that's not the same thing, so we're going to have to figure out what to do with that. And then we have some register function, and then that's going to make a function call with the parentheses, and it's going to pass in that lambda function. And then we have an empty line, and that's like a fill in the blank, and then we have line 9, and we do something there. So let's take a look at like this line right here, and like what do we put in here? Well, what happens is that if we look at the environment diagram at F1, notice how the function call is named vote. So that means vote is the first function that's called in the entire in this entire code. And so for that to happen, our first function call has to be vote. Because like if it isn't, then it's not going to be right here. And so what happens is that we're going to pass in this lambda function right here. And as we can see, vote does point to the parameter vote in the function vote does point to this lambda function defined in the global frame because we defined it there. And so now let's go through the vote function. So please is going to end up being like some like lambda function, and notice that it's not the same because its parent's f1, so it's going to be defined here. There's going to be a new lambda function. This would be, yeah. And so let's take a look at everything that could happen in these options. So we have vote of ty, and like if we notice with our vote function, it's going to return nav plus ty. And we know, nav plus ty is not going to be some function because like you can like never add functions. So it can't be these two. And what if it was vote? Well, if we went back to the environment diagram, notice how vote points to, the parameter vote that we passed in points to this lambda function, and please points to another. So that means that these are two different lambda functions, and as you can see, they're like defined in two different frames. And so that means they can't be the same thing, so it can't be vote. Oh, meant to cross them out, but yeah. So now we're left with all of these lambda functions, and yeah, we'll figure out what they do later. And so what we want to do now is let's go through the rest of the code. So it has to be some lambda function, lambda nav equals blah 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 blah. And then we have this line. And if we look at the environment diagram, third is going to become 4. And so ty plus 3 is going to be 1 plus 3, which is 4. And so this is going to turn into third. And then we're going to return please right here. And it's going to be the exact same thing as that. So everything seems to be working out nice for now. And register is going to end up being whatever this lambda nav is. And we'll figure what that is later. And so now we have line 8, and this is a fill in the blank line, so we can do whatever we want. And what we want to notice is that ty is still 1, and we have to change it to 3 somehow. So let's think about where we can change ty. We could change ty can we change ty in line 7? Like replacing this? Not really. Can we change it here? No, this is like a child frame and we can't do that. Can we change it in line 9? we can't like really make an assignment call inside of like the parameters. So that means that we have to assign ty to 3 here. So we're going to put ty equals 3. And that takes care of our problem right there. But now we have to go into this thing right here. So this is a register call. And if we remember, register is going to end up being this lambda function on line 2. So I'm going to replace this with like lambda nav just so we can see what happens. But what's going to happen here is that register is going to end up being that lambda function. And so it's defined in parent f1. And now if we go to the environment diagram, if you notice right here, that lambda function is being called with parameter 30. And since it was called with a lambda function, we know that the parameter probably can't be changed, because like, how are you going to change the parameter in a lambda function? Because you can't really fit an assignment statement in there. So we're going to have to do register of 30 somehow. And let's take a look at what we can do with our answers. So this is like, select all that apply. So ty times 10, well, what's ty? Ty is 3, and 3 times 10 is 30. So we check that. 3 minus 1 plus 30. That is 32. So we don't take that. We can check 30. And a third plus 26. Well, third is 4, but third is defined in like the parent frame. I mean the child frame, because this is where third was defined, but we're in the global frame right now, because that's where we're calling register from. And because of that, we can't do it, and it's going to error out. So we can't do that because of an error. And then for the last one, this is lambda function that we're passing 15 into. So we're going to calculate 15 plus 15, and it's going to be 30. And so this is what we want, so we're going to check that as well. And yeah, I'm going to fill in these ones. So third, and I believe part C was going to be vote. Yeah, and now we call register of 30, and then we have to figure out, what is this please function? So we call register of 30, and we get to this point. But then how do we get 37? And how the hell did we end up with F3? Well, if we look at all our options, we have vote of nav plus third, vote of nav plus third outside, vote of nav plus third inside, vote of nav plus ty, and vote of nav plus ty. It's kind of different. So let's go to our environment diagram and think about like what is everything so far. So if we notice right here, ty is going to be 3, and it's defined in the global frame. So ty equals 3. Third is going to be 4, and it's defined in the F1 frame, and we can access that because its parent is F1. So it's going to go like, what's third? Well, it's not defined here, so let's go to F1, and third is here, so it's going to be 4. And then after that, we're going to say nav is 30, because that's the parameter we passed in. And so now let's go through each of these examples. And also note that vote is the function lambda nav plus ty. And like this is defined in the global frame. So ty is also going to end up being 3 for now. So what's going to end up happening is, let's call it vote of nav. Well, nav is 30, and I'm going to take 30 plus 3 plus 4, and that's going to be 37. And that's what we want to return. Nice. But let's go through the other examples. So this is going to be 30 plus 3 plus 4 as well, which is 37. And we go like, why do we have two 37s? Well, let's keep going on. Vote of nav plus ty. So that's 30 plus 3 plus 3, which is 36. And same with this. 30 plus 3 plus 3, which is 36. And so since these equal 36, we don't want to include these because they're definitely not going to be our answer. But what about these two? Why did they both sum up to 37? And like there's only one answer. Well, we have to look back at the environment diagrams again. So if we notice here, if we look at F3, the NOV that's being passed in is 30. Well, let's go back and look at what's being passed in. Well, here we're passing in NOV, which evaluates to 30, but here we're passing in NOV plus third, which evaluates to 34. But we need to make the parameter 30, and because of that, we want to choose this one. So it's going to end up being lambda of NOV, vote of NOV plus third. And yeah, that's pretty much all for the environment diagram question. And if anyone's ever confused, I'm going to go over it again to show like how the environment diagram goes. And so what's going to happen here is I'm going to define vote, define ty. Now we make our vote call. And we pass in this lambda function that we defined on line 7. And what happens here is we're going to define please. So that's another lambda function. That's different and its parent's f1. And then we compute third, and that's ty plus 3. So that's 4. And then we want to return please. And register gets assigned to that because that's where you called vote from. That's what you assigned the vote call to. Now with the next line, ty becomes 3. And as we said before, we put ty equals 3 because, where else are we going to assign ty to 3? And then on line 9, we call register of 30 because we wanted the parameter 30 to be passed in. Or like any variation of 30 because they were like select all that apply. And then what happens here is that we're going to call this function, like the please function, and we're going to pass in vote of NOV. And if NOV is 30, so we're going to go into the line 7 lambda function. And then it's going to be 30 plus ty. Well, what's ty? And its parent's global, so we're going to look there, and ty is 3. So it's going to compute 33. It's going to return that. And if we go back to the line 2 lambda function right here, we're going to compute 33 plus whatever third is. And its parent's f1, so we look right here, third is 4. So we compute 33 plus 4, which is 37, and that's what's returned. And yeah, that's all of the environment diagram question, reverse environment diagram question, and be sure to let me know if you have any questions about this. And yeah, I'll see you on Tuesday. All right, have a great day.